I want to talk right now about using discriminant to determine the nature of the solution. Nature of the solutions means is it going to be real solutions, imaginary solutions, rational, irrational, maybe only one solution. Um, so we're going to talk about how to use a discriminant now. Discriminant is discriminant here. We're going to look at this right here. This is the quadratic formula right here. This part is the quadratic formula. And it all starts with having ax squared plus bx plus c equals 0. Once you have that, we can solve this. And we went through in class the whole method of completing the square using a, b, and c instead of numbers. And this is what comes out. So basically, we can solve any quadratic equation by plugging in the value of a, the value of b, and the value of c into the appropriate places. One thing we want to look at is what the solutions are going to look like. And really what that means is it's going to be determined by what this value is under the square root sign, because that's kind of a limiting factor. There are certain things we can't put under a square root sign, like a negative. Basically, if we have a negative number under a square root, so I'm looking at what we call just b squared minus 4ac, because that's the number that's underneath the square root sign. And that actually has a special name for that, and we call that the discriminant. Often, when we look at problems of this nature, we want to know what are our answers going to look like. Are we going to have positive? Are the solutions going to be real or they're imaginary? Are they going to be irrational, rational? We don't want to know all those things. Just by looking at this part right here, b squared minus 4ac, the part under the square root sign, we can determine what the nature of this is going to be. And the way to do that is we look at the value. So if b squared minus 4ac, first of all, if that's a positive number, if b squared minus 4ac, when I figure that whole thing out was a positive number, then we would have two solutions. Negative b plus or minus two different numbers, because whatever the square root would be. So basically, if it's positive, we look at we're concerning b squared minus 4ac. If that value is positive, then we have two real solutions. Now, there's a couple of things that we do a breakdown within the real solutions. If this number under the square root sign is a perfect square, so if it's a perfect square, would be a number that we can take a square root of and get no remainder left over. So for instance, 81 or 25 or 16 or a perfect square like that. Then we have the solutions are two real rational solutions, because a rational number is not going to have a square root left in it. If it's not a perfect square, then basically what happens is we're going to be left with a square root. If the number's like 10, square root of 10, there's no exact value, so you're going to have an irrational number. It's still going to be real, but it's going to be irrational. Sorry about that. So that's what we have. Now, that's to say if it's positive. Now, what happens if it's negative, or let's say if it's 0? Because it's possible that when I do b squared minus 4ac, I get a 0. And then when I go back to, then when I look back here, if this thing I circled here is 0, I'm going to get negative b plus or minus the square root of 0, which is 0. But something plus 0 is the same as minus 0. So really, if this number here is 0, then I have only one solution, and it's real. So one real solution. And it will be rational because the square root will be gone. Sometimes what they write this as, instead of saying one real solution, they'll say we'll say two solutions that are the same, or two equal solutions maybe. Because technically when you have a quadratic formula with the 2 here, means you should have two solutions. It just so happens that they're the same. So when I've solved it, I get negative b plus 0, which is the same as negative b minus 0, so it's the same number. Technically, it's two solutions that are same, that are repeating, or they say multiplicity of two, or one real solution. It's the same thing. On some tests, some state tests, they'll say two real solutions that are equal. And then they might say these are unequal. These up here are unequal. Same deal, same thing. Okay, and the last part is what happens when it's negative. Let's see if I can do this right. So if it's negative, when I say it, I'm talking about the discriminant is a negative number. What happens then is I look at my discriminant, that's this part right here. If that's a negative number, I have a square root of a negative number. So if b squared minus 4ac is negative, then I have two imaginary solutions, or complex solutions, depending on how we write that. We're going to say imaginary right now. Okay, now I'm going to do a quick example with 4 problems. First one is going to be x squared plus 4x plus 2 equals 0. To solve that, if I use the quadratic formula, I'm going to have x equals negative b, which makes negative 4, plus or minus the square root of 4 squared minus 4 times 1 times 2, all over 2 times 1. And that's going to be equal to negative 4 plus or minus the square root of 16 minus 8 over 2, which is equal to negative 4 plus or minus the square root of 8 over 2. The square root of 8 can be simplified to be 2 times 2 times 2, so that's going to be negative 4 plus or minus 2 square root of 2 over 2, which can be simplified to negative 2 plus or minus the square root of 2. That's that. Now notice a couple of things. The discriminant for this problem is what's underneath b squared minus 4ac. So 4 squared minus 4 times 1 times 2, 16 minus 8, which is 8. Now I can see it right here. And notice that 8 is not a perfect square, but it is positive. We have two answers, negative 2 plus the square root of 2 and negative 2 minus the square root of 2, but they're irrational because 8 is not a perfect square. So there's two real solutions that are irrational. Check back over here on our rules. It's not a perfect square, two real irrational numbers. It's positive, but not a perfect square, two real irrational numbers. Let's erase some of the stuff that doesn't have to be there. Okay, let's look at another problem here. So this is the nature of the solution. I don't have to go through this whole step. I could have just gone to discriminant, looked at this and said, because this number right here is positive, not a perfect square, I'd say two real irrational solutions. Okay, I'll show another problem similar to that. I'm just going to change one number in the problem. I'm going to say x squared plus 4x plus 3 equals 0. And if I were to do it the long way, I would say x equals negative 4 plus or minus the square root of 4 squared minus 4 times 1 times 3 all over 2 times 1. and that's going to be x equals negative 4 plus or minus the square root of 16 minus 12 over 2, which is negative 4 plus or minus the square root of 4 over 2, which is negative 4 plus or minus 2 over 2, which is negative 4 plus 2 over 2, which equals 2 over negative 2 over 2, which is negative 1, or negative 4 minus 2 over 2, which is negative 6 over 2, which is negative 3. So there are two solutions to this, negative 1 and negative 3. Both will make this statement true. Notice that if I just went for the discriminant, I gotta spell that right. Okay, let's get that better. You can't even read that. Okay, the discriminant is just the part under the square root sign. So the discriminant is b squared minus 4ac, which is 4 squared minus 4 times 1 times 3. This 4 is always part of all of it. The 1 times 3 is the 1 here and the 3 here. So that's going to be 16 minus 12, which is 4. 4 is positive and it's a perfect square. We go back to our rules. It's positive and a perfect square, two real rational solutions. So I'd say there's two real rational solutions. And I can look at the answer, negative 1 and 3. Negative 3 are both real and rational. So that's the solution. I don't have to do all this stuff here to find out that there's two real rational solutions. If I were asked what the solutions were, then I would have to go through that, or factoring, or something else. But if they just ask for the nature of the solutions, this is what we write. Okay, and we're expected to kind of know how to do that. Let's look at a couple of more. How about something like this? We'll do something very similar. X squared plus 4x plus 4 equals 0. Okay, if I'm going to solve that, I'm going to say x equals negative b, so negative 4 plus or minus the square root of 4 squared minus 4 times 1 times 4. Remember, this 1 is the coefficient here. This 4 is the c, and that's always part of our problem, over 2 times 1. So that's going to be x equals negative 4 plus or minus the square root of 16 minus 16 over 2. So x equals negative 4 plus or minus the square root of 0 over 2. So that becomes basically negative 4 plus or minus 0 over 2. So technically the two solutions are, it always has two solutions if it's a quadratic, but in this case it's going to be negative 4 plus 0 over 2, which is negative 4 over 2, which is negative 2. And negative 4 minus 0 over 2, which is negative 4 over 2, which is negative 2. So there's two ways of wording it. There's two real solutions that are equal, or realistically there's just one solution because it's the same number. Okay, and the last problem, and let's look at this, I'm sorry, if we were to do just if I said the nature of the solutions, we'd say discriminant. Discriminant is b squared minus 4ac, which is 4 squared minus 4 times 1 times 4, which is 16 minus 16, which equals 0. I'll go back and look at our rules for that. It's 0, I got one real solution or two real solutions that are equal, however we want to word it. Okay, and the last one I want to do is similar. I'm just going to add one more step to it. X squared plus 4x plus 5 equals 0. And now x equals negative 4 plus or minus the square root of 4 squared minus 4 times 1 times 5 all over 2 times 1. That would be negative 4 plus or minus the square root of 16 minus 20 over 2, which is negative 4 plus or minus the square root of negative 4 over 2, which would be negative 4 plus or minus 2I over 2, which I can reduce both of these by 2 to be negative 2 plus or minus I, which basically is negative 2 plus I and negative 2 minus I. Now, if I were to do it just to find the nature of the solutions, again, I would use the discriminant. And in that case, I'm going to say negative b squared minus 4ac. That's all I'm looking at, the part that's under the square root sign. It's going to be 4 squared minus 4 times 1 times 5, which is 16 minus 20, which is negative 4. Since that's a negative number, let's look at our rules here. How do I do this? The negative, I have 2 imaginary solutions. So that's, let's see if that works for this one. We have 2 imaginary solutions, the complex solutions. So that's that. So that's the second part of the work that we're going to go over tomorrow in class. Okay, that's about it. Let's see what I got.